Okay, so in the pre-video notes, I included a couple of limits that I asked you to calculate. So this is an example of the first one that you were asked to do, and now our goal is to rigorously prove that the result is as we say. So hopefully what you arrived at for your proposed limit is that the limit of 1 plus 1 over n cubed turns out to be 1. And kind of our calculus 1 version of that is that as n gets big, n cubed gets really big, so 1 over n cubed gets small, it goes to 0, and so we end up with the 1. All right? But we should really be able to prove something like that. So let's see if we can. So our claim is that our limit is 1. And so we want to start by considering the difference between members of the sequence and our proposed limit. All right, so in this case, the a sub n is 1 plus 1 over n cubed. And we're subtracting our proposed limit from that, so it's minus 1. Now frequently, once you have this set up, you've got some algebra to do. There's not a lot to do here. The 1's do cancel. And so I get 1 over n cubed. That's inside absolute values, but because n is a natural number, I am not going to get any negative values. So I can just dispense with the absolute values and write 1 over n cubed. Now, what we're trying to do, remember, is arrange for the an minus L, which we simplified to 1 over n cubed. We want that to be made less than epsilon. So this is what we want to have happen. So we do some more algebra to figure out how big n has to be in order for this 1 over n cubed to be less than epsilon. So 1 over n cubed is less than epsilon. That happens when 1 is less than epsilon n cubed. And that happens when 1 over epsilon is less than n cubed. And so if I take the cube root of 1 over epsilon, that's going to give me a big enough n. Right? So from this, we're kind of working backwards, right? We start off with the thing we want to make less than epsilon and kind of work back to the n that would make that happen. And once we're here, this is sort of the work of the proof. And now to give kind of a nice version of the proof, we fit it to the definition as follows. All right, so here we're going to take my capital N to be anything that's bigger than cube root of 1 over epsilon. Right, so to finish off the proof, we'll say let epsilon be bigger than 0 and take capital N to be anything bigger than the cube root of 1 over epsilon. Then, if we go out that far in the sequence, we get a sub n minus L is 1 over n cubed, and that's less than our specified epsilon as required. Right, so that completes the proof. Now, a common question on these sorts of problems is kind of what I want to see when I ask you to prove a limit, and it's pretty much all of it. The first few steps is the work you do to figure out how big your capital N needs to be. And then the last piece is to write it up kind of formally so that you show that you understand what it is you've done and can fit it to the definition. Right, so that's our first example. We will do some others.